You'll recall with Pythagorean Theorem, the lengths of the sides in a right triangle are related by the rule c squared equals a squared plus b squared, where c is the longest side in the triangle. The longest side in a right triangle is always found across from the right angle, and we give it the name c. The legs are a and b, and those are interchangeable in terms of their labels. So in order to find the area of the larger square, you have to add the area of the two smaller squares. And if you're looking for one of the smaller squares, you have to subtract the other leg square from the hypotenuse square. So that's how Pythagorean theorem works. Let's see what happens when we put some numbers onto our triangle. So if the hypotenuse in our triangle has a length of 5, and the leg A has a length of 4, then you're going to start by drawing squares on each of the sides and finding the area of each of those squares. If we know that the big red square on the hypotenuse side has a side length of 5, the other side must also be 5 because it's a square, and 5 times 5, or 5 squared, is 25. So the area of c squared is 25. The area a squared is similarly going to be 4 times 4. Multiply the side by itself because it's a square. 4 times 4, or 4 squared, is 16. Finally, we want to find b squared. We do not know length of b. So what we're going to do, because we know the big square's area and we know one of the smaller squares' area, is subtract. So you might remember rearranging our formula a little bit. We want to know b squared. So we're going to have to take c squared and subtract a squared. So b squared is going to equal 25 minus 16, which equals 9. And then your last step to undo a square, hopefully you remember that the inverse operation of squaring something is square rooting. So b is going to equal 3. So this is my famous 3, 4, 5 right triangle. This is going to come in handy when we're working with a 3D shape like a cone, and we're given the slant height and the radius, but maybe we don't know the height of the cone, and so we can't find the volume without that. Let's look at another example. The ramp below is 12 meters long and has a base of 10 meters. So we know 10 meters, we'll call that A, and we know 12 meters, we'll call that C because it's our hypotenuse. It's located across from our right angle in our triangle. And we're looking for our B. We just saw that when we know the longest side, we're going to have to subtract the square of the longest side minus the square of the leg that we know. And that's going to give us the square, or the area, on the missing side. So we're going to start by doing 12 squared which is 144. And then we're going to do a squared, which is going to be 10 squared, or 100. And b squared is going to equal 144 minus 100, that difference, which comes out to 44. So b squared equals 44. To get b by itself, we're going to square root 44, which gives us approximately, I think it's about 6.6. So we'll say 7 meters, and that's rounded to the nearest whole number, and that's answer B in our multiple choice. You'll notice that even though this was a multiple choice question from EQAO, I took the numbers from my picture, I did my calculation, and then I checked to see what the best answer was.